Hello to everyone from Prota Software. My name is Caglar, and I'm working as a sales engineer in Prota Software. I hope everyone is healthy during this coronavirus outbreak. And let's start. Today I'm going to be doing beam slab design using various methods, and we'll be doing stairs modeling using plane definitions. If we keep on going, just right. You can see contents of today's webinar, and we'll be modeling and including the stairs in the analytical model. We'll be performing FE analysis of beam and slab floor, and we'll go further into detailing in product details. We'll be working on this model here today, and I'll be doing it from scratch, and we'll be proceeding with the post-analysis result display for the combined analysis of stairs and structure. Okay. You can ask your questions through email at globalsupport@protasoftware.com, and now we can go live to ProtaStructure. I have pre-modeled this model here. What I did was I used this architectural drawing. This is a DXF file, and what I did was I imported the model. Also, I imported the shear walls and the columns as well. And I'm going to import it again, just very quickly. And I'll be selecting my unit, which is meters in this case. And it will appear just like so. So if we focus on here, we have a stairs here. We have a story landing here and intermediate landing right here. And what I'm going to start with is I'm going to set up the axis system for my model. First of all, I'm going to go axis in this direction here, and from here to here, and I'm going to create my stairwell just like so. Okay. Now I will just quickly stretch my axis. Just right click and stretch the axis just like so, and do the same in this direction here as well. And I'll be doing the same here in order to intersect with the other axis here. And I'm just going to do it quickly, just like so. So I'm going to do the bottom as well in Y direction, and just stretch my axis in the bottom, just like so. Okay. So now my axis system is ready. We have a stairwell here. We have a story landing here and intermediate landing right here. I'm going to start creating my slabs in this case. Before we go, you all know slab additional loads. You can edit your additional loads if you have any in your slab. And I can quickly go to slab properties, and I'm going to type 15 centimeters for slab thickness. You can go to loads, then just type in your DAD loads and live loads here, just like so. We have different insertion options for slabs. You can axis region, beam region, pick up axis. You can pick up axis, or you can pick up, and that's what I'm going to do in this case. I'm going to pick up 4 points now. I'm going to pick up this point right here, this point here, and this point here. So my slabs are now created for story landing, and I'm going to create the intermediate landing now. Again, I'm using the same insertion option. I'm picking up 4 points, and it can be created just like so. Just do it again. Just click on different one, and here and here. Okay. And just like so. Okay. So what I'm going to do here, I can come here to this axe here, and I'm going to actually offset this axe in 50 millimeters to make a hole here. I'm just cutting the, I'm just not making a intersection here with this beam and this slab, and I'm going to do the same here just so you can see it much better. And again, 50 millimeters here. Okay, so I'm going to go to slab properties again. You can again pick points, and I'm going to pick this point here. I'm going to pick this point here. I pick this point here and this point here. Okay, so delete all axes and do the same for this slab here. Okay, we quickly select 4 points and it'll be created just like so. So you can have a look at in 3D as well. I can just pull this along here so that you can see. This is now modeled in 2-dimensional now, and I'm going to make plane definitions now. In order to do that, I can go to plane definition options right above here. And you'll see in the properties, you'll see 3 points here, which is referenced in the slabs. And from the insertion options again, I can pick up points again. I can do the same. And I'm going to make a plane definition for this slab here. Again, I'm picking up 4 points. And I'll just quickly do that again. I can come here and select these points, and my plane definition number 1 is done. So this side here, you can see is coming from the story landing. And as I mentioned the points here, it's referenced and shown in the in my plan. I can change the locations of my points if you like to. Maybe I would like to, in this case, change number 2 to in this corner here, and just update it, and it can be changed straight away. Now I can type in my levels. This is the story landing side, so it is we are going to keep them 0. But this side is coming to intermediate landing, which is half of the story height. We have 3 meters of story height. You can check out in the edit story section. So for the point number 3, I'm just typing in minus 1.5 meters. Just update it, and when you move members to plane definition, it will be created just like so, as you can see in the 3D view. Now I can come to this one here. Again, I'm going to select plane definition, and from the insertion options again, I can come here and select 4 points. I select this point here, this point here, and this point here. I'm just going to okay, I have created my plane definition number 2. Now I can create my I can type in the levels again. Maybe again I want point number 2 to be in this corner here. I'm just going to select this arrow here and just insert it wherever you want to locate it. And just like so, you can create your plane definition. And what I'm going to do here, this side is coming out of the foundation level. So our story height was 3 meters. So I'm just going to type in -3 meters to give an incline to the slab. And I'm going to keep point number three as the same, which is -1.5 meters. Just update it and move members to plane definition, and it will be created just like so. Okay. So thirdly, we're coming to this intermediate landing here in this case. And again, I can do my insertion by picking up points. I'm going to come here, pick up this point, pick up this point here, this point here, and this point here. Sometimes you have to do it twice. By picking up axis, it might be easier for you. And I have created my plane definition number 3. And all the levels in this case are going to be the same, which is -1.5 meters from the story level. And just like so, just update it. Okay. In this case, what I want to do here is I want this beam to be defined along with the plane definition. So what I'm going to do here, I'm going to select this slab and select this beam as well. And I'm going to right click, set plane definition to members, and just with one click to plane definition, select yes, and my story intermediate landing is created just like so. Okay, so it is well easy to create these, and as you can see, it's perfect. And if I go further now, you can see my model. I have line loads in my slabs and another line load here in my slab. I have created some beam loads as well. Now I can go straight to story generation. What I'm going to do straight away is I'm going to define my story height. I want six story building here in this case. And I'm going to come back to my source story. I'll generate my stories, and selecting the source story, I'm going to select the rest of the stories and just hit OK. And stories will be generated just like so. Okay. So we are now in story number 6. Maybe I want some flat surface on the top here. I'm just going to select the whole system. I'm going to delete the beam wall loads. Okay. And also I want to delete the slab loads as well. Just like so. Okay. So before we go any further, I would like to show you a trick in this case. Let's go to story number 1 here. If you focus on this inclined slab here, it is coming out of the foundation level. So it needs to be supported. Okay. It needs to be supported. So I'm just going to make a quick trick here. What I'm going to do here is I'm going to create a shear wall here to support this slab, okay, inclined slab. So what I'm going to do, I'm going to type in -3 meters to del Z from top, okay, and I'm going to create my shear wall here, just like so. Okay, I can come here and change this extension as well. Now I have created a support for this slab. I'll show you further in the post-analysis results how it is supported. This is a trick you can use. Okay. And now we can go straight to slab design. Okay. Before we go to slab design, I would like to show you the slab settings, design settings. You can see you can come here and select minimum steel bar for your designs, bar spacings, and other parameters can be selected in the slab design settings here. Okay, and now also you can you can set slab types automatically as well. Maybe in this case right here, just like so. And now we can proceed with the slab strips. Okay, we have 3 different types of slab strips: analytical strip, finite element strip, and first I'm going to go for analytical strip. Okay, so before you start, you have to determine the start and end points as well. So if you have a slab before your strip, you have to select this option here. If you're starting with a beam, you have to select the one in the middle, which I'm going to do now. If you had a cantilever before you start, you will have to select this option here. So you need to determine the start and end points as well. So quickly, I have my directions are X direction. I'm going to cut a strip through here on the slab. So as you can see, the design is done instantly. I'm going to cut a strip through here on this slab as well. So as you can see, slab design is done instantly. In this case here, I'm going to cut a strip through this 2 slabs because I have already cut a strip and on this slab here. So I'm going to choose slab on this one, and I'm going to just type in a distance, which I'm going to do 50 centimeters in this case, and I'm going to cut a slab strip through here. Okay, as you can see, the rebar design is done instantly in this case. Okay, and here as well. So I'm going to go back to directions. I have done in X direction, and I will do in Y direction in this case. Okay, so I'm going to cut a strip through here and here as well. Okay, so don't forget to I won't forget to mention that you have to cut the strips from left to right and bottom to top. Okay, don't forget that. Left to right and from bottom to top. The strips has to be cut. And this way, this is a very quick design, and it can be done very quickly, just like so. You might ask, what's the difference between finite element strip and analytical strip? And basically, when you cut analytical strips, the calculation method in this case is that you can see these line loads here. When we perform when we cut analytical strip, these line loads are divided into the area of this particular slab, and it is added to the dead load of the slab. This is how it's different from finite element analysis, but it is much quicker. It's less accurate than FE strips, FE design, but it is much more faster. Okay, so this is the calculation method here. In this case, I'm going to jump into another model here. I have modeled some additional cantilever on top in this case. It is exactly the same one. I have done the, let's just go straight to my plan view. And I'm just going to quickly arrange the views for you. And you can see this is exactly the same model. I have done the analytical strips. And we can go to story number 2 now, and I will show you the finite element strips. In final element strips, we have 5 different options here. Okay, so one is span strip, which we are going to do now. We have rib strip on its right, span band strip, support strip, and fixed span strip. Okay, we're going to use the span strip in this case. It is the same way basically. I'm going to you can change the extraction here. Already these strips are already cut, so this is the exact same way you cut the strips with analytical strips. I'm not going to do it again, but you need to come here and select find the element strip, and from the 5 options here, you have to select the desired ones. Okay. So now we can go straight to our analysis. Okay, my strips are done, and let's go straight to find elements. Floor analysis. You can come here and edit your materials. Desired rebar diameters, rebar type, concrete type can be selected here. You can include the column sections in the E model here. And quickly, I'm going to mesh my floor, and it will, again, this is a 2-dimensional analysis, okay? So it will give me a warning which says there are some members that is lowered using del-Z, and they're going to be accepted as horizontal. So I say yes, and I'm going to quickly generate the model. You can come here and select change the uniformity factors here. You can just do the generation. I want to come here and focus on this slab right here, and I will show you how FE analysis is different. You can see from our line loads how these loads are distributed perfectly in this slab. Okay. So basically, when we perform FE analysis, these wall loads here will be added as nodal loads in the mesh flow, just like you can see here. This is much more accurate than analytical strips, or general ways of analysis. You can see the distribution on the slab picked up by the nodal loads. Okay. So you can proceed to analysis post-processing and start the analysis of our floor. Okay, so you can see the model here. Let's just again focus on the plan here. We can we can check out the contours and displacements in our floor. You can see from the legends, in this case, we have around 16 millimeters of displacements on these slabs here. You can check them out under different loadings. From here, you can check out whichever loading you would like to see here in terms of displacement. You can also come and check out the moments here, bending moments in X, bending moments in Y, design moments in bottom, design moments in top can be selected, and also required steel areas can be evaluated here, just like so. Okay, so you can evaluate your axis as well. Let's have a look at diagrams of X1 axis here. You can check out the displacement diagram, moment diagram, and design moment diagram for my X1 axis. You can also come here and play an animation as well if you would like to see the displacements. Okay, and you can increase the scale if you like. See the animation. Okay, so if you're happy, just turn it off, and we can start transferring the strip results to our model now. Just in a few seconds. Yeah, it is transferred. You can also export your model to SAP if you would like to. And in terms of design, I'm going to come here and right click, and I'll update the steel bars, and you can see the steel bars clearly just like so. Okay. So this is how we do the FE analysis for our fitted for story number 2. And this is much more accurate than analytical strips. I would recommend to do this in every case. So we can now go straight through our top floor. Okay, let's select this one here. And as I said, I have modeled a cantilever around this, around the story number 6. What I'm going to do here, and I'm going to come to slab strips again. And this time I'm going to cut an analytical strip again using cantilever option at start and end, because I have cantilever, as you can see. And I'm going to cut a strip through here. Okay. And I'm going to cut a strip through here. Let's just, we can change, I forgot to change the name. And just update it. Okay. So you can come to Y direction. I'm going to keep it cantilever at start and end, and I'm going to cut a cut one through here in Y direction. Okay, let's come in here and focus on this cantilever here. I'm sorry. You can see in here these rebars in Y direction, which I just cut the strips for, are the actual ones carrying this cantilever. Okay, so we need some rebars in X direction here that doesn't require any design. So that's what when I use manual strips. Okay, you can come here and select what you want to use. Let's use 10 in this case. Spacing could be 250 millimeters, and for bottom and top steel that can be arranged. And I'm going to cut a strip through this cantilever as well, just like so. What I have selected is just given in the in your just like so. So you can come here and create the same axis for the rest of the cantilever. So that's when we use manual strips in ProtaStructure. Okay, so let's just turn it off. And what we can do now, let's have a look at the stairs now. Okay, I'll go straight to story number 4, and I'm going to cut strips through my stairs in order to analyze it in 3D. The ones that we have done until now was 2-dimensional. Now we're going to do 3D design. Okay, again, I'm going to select slab strips. I'll come to select the finite element strip again. This time I'm going to use fixed span strip. Okay, out of the 5 options we have for FE options, I'm going to use fixed span strip this time, and I'm going to cut a strip through here. Okay, I can come and just determine my borders for my span. Also, I'm going to cut a strip through here. I didn't pay attention to the directions. It doesn't matter. I'm just doing it quickly this time, and it won't change anything. Just in the reports and detail links, it will be the different name. And I will cut a strip through here. Sorry about that. Here and here. Okay. Again, I can come here and select my borders. Update it. Sorry. So it was this one here. I can come here and update this one and this one here. This can be quickly I can update my folders just like so. Okay, my strips are ready, and now I can proceed with the analysis. Okay, I'll go straight to building analysis, and out of model options, I can come here and select finite elements shell model for my shear walls. And slab models are important. Here, you have to select a non-rigid diaphragm for floor levels. I came here and just mashed all the floors in this case, because we are adding the stairs in the system. Okay. I've created my shell element size in 1 meter minimum and maximum, and I put my stiffness factors. So I can just go ahead with the analysis. The analysis is already done in this case, and I'm going to go straight to post-analysis, okay? So I'm going to now evaluate my building in post-analysis. The aim here was to include the stairs in the analytical model so you can evaluate with it, okay? As you can see in the post-analysis results, my stairs are matched perfectly along with the intermediate stories. And I'll come here and focus up in here. My trick has worked. As you can see, I have defined a shear wall here, and this inclined slab here is perfectly supported by the shear wall. Okay. And also, we can go ahead and play an animation in order to see the displacements under different loads. And you can come here and evaluate this. You can see how well it is moving with the how well our stairs are moving along with the along with our structure. So I can just turn this off, and let's have a look at the contours quickly. And let's have a look at the vertical displacements in this case. And I will create the legend here as well. Just like so. Just a few seconds. And my legend is created. You can see the displacements here. Let's just turn off the shells so that you can see better. Right. And also, you can have a look at these under different load cases, load combinations, and also let's just turn this off. And I'm going to turn off the contours here. You can see how well it is matched, and you can see the displacements here. I'm going to turn off the contours here and open up the shells again. And let's have a look at some diagrams. Let's have a look at axial load diagram for my. Let's turn these off as well. The shells this time. And you can see it much better in this case. And from results, I can just turn up the results as well. And you can check out the axial loads, torsional loads for the shear walls. Shear force 2 diagrams can be seen here. Moment 2 diagrams can be seen right here. Also, shear force 3 diagrams and moment 3 diagrams that can be seen just like so. Okay. So we have evaluated on different loads. You can see how well it is matched, how well it is moving. Our stairs are moving along with the structure. This is a method you can use for if you want to include the stairs in your analytical model. So let's just turn it off and let's have a look at our slab design. I have matched my FE model, as you remember, and you need to match your stairs before the analysis, and you can see now in 3D, okay, the stairs, and again you can play animations. You can have a look at the displacements. Again, bending moments can be seen here around X and Y, and required steel areas can be seen here as well. You can have a look at the strip results as well quickly, and this will take a couple of seconds. I have now included the stairs in our analytical model and analyzed it all together if you want to do that. But still, I suggest you to make the design of stairs in the Prota details, which we have a perfect editor for stairs. And I'll go further to that after the transferring the results. You can see the process here. I think it's the last strip is being transferred. Then you can have a look at the rebars if you would like to see it. And you come here and let's go straight with 3. It was marked as well. And you can update the steel bars and have a look at the steel bars. But still, as I said, I suggest you to do the design in the product details. Okay. Also, if you would like to see the design reports, come here. For example, for story number 2, which we did FE analysis. Come here to Slab Strips, and if you want to have a look at the reports, you can create reports just in a few seconds for both analytical and FE strips. This is our mashed floor, basically, and you'll see the design in a few seconds, design report. You can come here and evaluate this if you would like to. Okay. So now we can proceed to product details for further detailing. And what I'm going to do here is I'm going to quickly load the product details for this case. Let's just say yes. And as you can see, we perfectly analyzed our building along with the stairs. We have been getting queries about this, and I wanted to show you how it can be done with this method I just used. The product details is being loaded, and I'm going to create my drawings in just one click right now. And out of the screen, I'm going to select auto generate, and I'm just going to generate my form plans here because I haven't done column design. I'm going to create these 2 floors, 1 and 2, floor number 6. I want to insert it to sheets, views A0, as you can see. I chose form plan, and you can just draw the form plan straight away with one click, just like so. Okay, show you what I can do. Now, if you just focus on this is story number 1, I suppose, yeah. And what I'm going to do here is I'm going to cut some form plans, and you can use it's 118, okay. And you can come here and type the parameters here. In this case, we have a story height of 3 meters. This was 1180, and our stair width. Let's have a look at our stair width here, and just measure it from here to here. It's 1200. You can come here and stair width as 1200, and you can put all the other materials. Plate thickness can be entered, and you can change these, and you can make a quick design here. Also, you can come here to settings and select your minimum rebars here. Maybe I would like to select 10 millimeters in this case. Again, minimum bar spacings can be selected. Distribution rebar diameter can be selected. Hit OK, and if you make another design, and you can have a look at the design report here as well. It will be created just in a few seconds. You can see the parameters here, and also if you would like to pick up the drawings just with one click, you can pick up your detailed drawings just like so. As you know, Prota Details is the rebars here are interactive. So if you select this one, for example, and if you want to create a quantity table for this exact one, you can do it with only one click, just like so. Okay. So it will be because it is interactive, it will be deducted from this quantity table right here, and you can see the quantity table for only this drawing here right away. Okay, so I strongly suggest you to make your design detailing here for your stairs. What we have covered today is that I included the stairs in my analytical model. We did slab and beam and slab design for with three options: analytical strip, FE strips, and manual strips. I have mentioned the differences, what they're used for, and then we proceed on with the post-analysis results, where you could see how we can handle the structures with the stairs included, and you could see the reactions and displacements in the post-analysis display. This is all. We came to the end of our webinar today. You can always visit protasoftware.com. We are keep testing our brand new 2020 version currently, and it is going to be revealed in the following days. And if you have any questions, please you can ask to our email at globalsupport@protasoftware.com. Thank you for listening, and I wish you all healthy and safe days. Thank you for attending. Bye-bye.